So in today's video, we're going to cover section 2.3, which is quadratic equations in one variable. We're going to learn how to solve quadratic equations by factoring. We're going to learn how to solve equations by completing the square, and we're going to discuss the quadratic formula. And if we get to it, maybe some gravity problems. So a quadratic equation in X is an equation that can be written in the standard form ax squared plus bx plus c equals 0. Here, a, b, and c are all going to be real numbers. A cannot be 0, otherwise it's not a quadratic because it's not a second degree equation, but it's possible for b and or c to be 0. Now, while this standard form is set equal to 0, sometimes you're going to see a quadratic equation that isn't in standard form, and you need to be able to recognize it then as well. Below, you see the zero product property. This is something you've probably used before to solve quadratics via factoring. The zero product property basically says if some things multiplied together equal 0, then at least one of those things is going to be 0, right? You must be multiplying by 0 to get 0. So the way we solve quadratics using the zero product property is we make sure our quadratic is set equal to 0. We factor, and then we say, okay, any one of our factors equaling 0 would make this equation true. So we pull out each our linear factors and set them equal to 0 and see what values of x would make each of these factors equal to 0. Okay, remember, any one factor being equal to 0 will make your equation true because you only need to multiply by 0 once for everything to become 0. So that's the zero product property where we use factor. Another way quadratics is using the square root property. Basically, the square root property says that if something squared, say our x squared equals some c, then x is going to be plus or minus the square root of c. Basically, this is just saying we can square root both sides of an equation. We just have to remember to include that plus or minus possibility because x being squared means that the positive or the negative value of x is going to give you that positive c. Or if c is negative, then we are going to get imaginary numbers, imaginary solutions. So some examples here. If x squared equals 25, the square root property says that x is either 5 or negative 5 because the positive square root of 25 is 5, the negative square root of 25 is negative 5. And you can check that answer, right? 5 squared is 25, but negative 5 squared is also 25. All right. This one here is a little x squared equals 0, so x is going to be 0. But x squared could equal a negative number. And if something squared is equal to a negative number, we know there's no real numbers that when squared are going to give us a negative number. So that makes it an imaginary number. So you square root both sides of this equation, and the square root of a negative 81 has this square root of negative 1 as one of the factors. And so we use I to represent the square root of negative 1. Square root of 81 is 9, plus or minus 9. And then this I is that square root of negative 1, the imaginary part. Okay. So solving quadratic equations, we're going to use completing the square and the zero factor property. So keep in mind, a quadratic equation is a second degree equation that can be written in this form, ax squared plus bx plus c equals 0. And a cannot be 0. So like we discussed, our zero product property just has us set our equation equal to 0 and then set each factor equal to 0 to figure out what values of x make those factors 0. So in this case, we've got a quadratic that's been factored. X can be a positive 4 or a negative 3. In either of those cases, one of these factors becomes 0 and this equation will equal 0. Right. Just keep in mind, since we're dealing with second degree equations, we are usually going to have two solutions. Now, the square root property is fairly intuitive, but you might not have used it as much. It basically lets us take the square root of both sides of our equation And we have to remember that our solution is then going to be plus or minus the square root of that value. So for example, if x squared equals 9, we can square root both sides, and then x is going to be plus or minus 3. And go ahead and check how if x is 3, 3 squared is 9, but if x is -3, -3 squared is also 9. Sometimes equations might look a little more complicated, but we can still use our square root property. So if we see something like this, our variable is just this single variable x being squared. So we're going to add 14 to both sides, divide by 2, and then we've got our x squared is 7. So we're going to have plus or minus the square root of 7. Oops. If we have something like this, again, we can just take the square root of both sides. We're going to simplify that plus or minus the square root of 12 is going to be equal to x plus 1. So we have to subtract 1 from both sides. So we get this -1 plus the square root of 12, which is 2 root 3, or -1 minus the square root of 12, which is 2 root 3. Okay. Now, if we have to take the square root of a negative number, just remember you have to throw that I in there, okay? So sometimes we're going to solve quadratics using the zero factor property, and sometimes we're going to solve quadratics using the square root property. If we want to use the square root property, sometimes we will have to do what's called completing the square. So as you saw in those previous examples, we could solve quadratics. That are kind of already partially solved for us. Those quadratics, let's actually go back to that slide. These quadratics we saw at the bottom are already in a nice situation where there's only one single value of x here. So we are in a nice place to just kind of rearrange stuff and then take a square root, right? So it's easy to use the square root property in that situation. But sometimes our quadratic is going to have 3 terms, an x squared term and an x term, okay? In this case, we are going to complete the square to turn it into some kind of a perfect square where we can take the square root of it, okay? So take a look at this equation right up here and notice that if we have an x squared term and an x term and a constant term, that if the coefficient on our x term, if we divide that by 2 and square it, and then if that is our constant term, if this constant term has a special relationship to the coefficient on our x term, as outlined in this equation, then this thing is a perfect square and will factor to this perfect square x plus b squared, okay? But for factor into a square, a perfect square, we need our constant term to be to have this relationship to our coefficient here, right? Namely, whatever the coefficient on x is, if you divide it by 2 and square it, that needs to be what our constant term is. Remember, when we use this square root property, we don't have to have our equation set equal to 0, which allows us to engineer this constant term to be exactly what we want it to be by putting the other constant term, whatever's left over that isn't part of that constant term, but is still part of our equation, we can just throw it on the other side of our equal sign because we don't have to be set equal to 0. So let me show you how this works. Here we've got our equation x squared plus 2x minus 4 equals 0. All right, in this case, our b term, right? So b, notice, is half of the coefficient on the x. All right, so in here, the coefficient on x is 2. So if we divide it in half, our b is 1. And then if we square that, b squared is 1. So that tells us that the constant term that we need is going to be 1. All right. All we did to figure that out is we took the coefficient on x, divided by 2, we call that b. It's also going to be the b that we factor to. Squared it to get our b squared. So now we know that we need this, this constant to be a 1, a positive 1. Well, we can do that. Just move the 4 to the other side, subtract 4 from both sides, and then add 1 to both sides. So we've created our b squared term, our constant term, to be exactly what we need for this quadratic to factor as a perfect square. Okay. I just simplified on the right-hand side, and now we'll complete the square. So what that means is just factoring this guy, right? When we want to factor this, we say, okay, what two numbers multiply to 1 and add to 2? Well, that's 1 and 1. They're the same factors, so it's a perfect square. So this step here was just that regular factoring that we've done a million times with quadratics, but we notice the factors are the same, so we can write it as 1 factor squared. So what we just did is complete the square. Now notice how we had x in 2 places. We've only got x in 1 place. We can take the square root here. We take the square root of both sides. When you take that square root, make sure you're putting the plus or minus on the opposite side from the squared. And then we just work through the algebra to get that x can be -1 plus or minus the square root of 5. Okay. So that's how you use completing the square. You can do this to solve any quadratic. Specifically, if your quadratics don't factor, you can use this. A lot of people choose to use the quadratic formula when their quadratics don't factor. But once you get good at this step, it's actually just as fast as using the quadratic formula. Okay. It's also nice to be able to see how you can engineer your equation by just using the properties of equality to move things around, to kind of reorganize in a way that you want. Okay. So these skills that we kind of did in the middle here, where we said, hey, I want a +1 here, we can get a +1 there without really changing our equation. We're just going to move the 4 over, add 1 to both sides. And then this equation here, where we've got a +1 on the left, is the same equation that we started with. We just moved some stuff around. Okay. So that's completing the square. If you want to pause here and really look at what we did, go ahead and do that now. Okay. Here, I just outlined the steps for completing the square. Remember, completing the square is essentially we are engineering a constant term that's going to allow us to factor as a perfect square. We use the property of equality to do that by moving the constant term out of the way or to the other side. I say left and right here. You can choose which side you want to put everything on. It's a little trickier if we have a coefficient on the x squared term. We'll have to divide that out. And then we just have to find the constant term we want, add this number to both sides, and factor as a perfect square. Okay, and then you can use the square root property. So I have a couple examples here. I'm actually going to do the second example first because it's a little bit easier. And then I'm going to do this first example with the coefficient of 2. It's a little bit trickier, but I'll show you how it works. So let me share my whiteboard with you. Let me share my whiteboard and we will do this problem. All right, so we're going to do the x squared plus 5x minus 3 equals 0. All right, and first, before you complete the square, you might want to say, hey, I can, maybe I can factor this. If we wanted to just factor this and use the 0 factor property, we'd have to find two numbers that multiply to -3 and add to 5. The only things that multiply to 3 are 1 and 3, and you were never going to get those to add to 5. So this won't factor. Okay, that's why when we see that it won't factor, we either have to use this square root property by completing the square or the quadratic formula, which I will show you after this. So what we're going to do is we're going to say that our b is going to be 5/2, right? It's this term divided by 2. And so that means our b squared is going to be 25 over 4. All right. So we have to move our -3 out of the way and add 25 over 4 to both sides. All right, so we moved our 3 to the other side and we added a 25 over 4 to each side. Okay, now we are going to factor what is on the left-hand side. Now we know that if this number divided by 2 squared is our constant term, that this will factor as a perfect square. And the piece of the perfect square is going to be this b, 5 over 2. So it's going to factor to x plus 5 over 2 squared. All right, so that's our left hand completed the square. Now on the right hand side, we've got this 3 plus 25 over 4. Let's see, what's the easiest way to write this? 3 is 12 over 4. So we can add that and we're going to have 37 over 4 over here. Okay, we just have some fractions. It's not a big deal. Now we can use our square root property, right? Because we've got a perfect square on the left and we've got a just a number on the right. So let's take the square root of both sides. So I'll square root the left, and when I square root, since the left is a perfect square, when I square root the right, I'm gonna have to put a plus or minus here. Okay. So the left was a perfect square, so it becomes x plus 5 over 2, and the right is going to be plus or minus, I'm going to simplify this, square root of 37 all over 2. I just took the square root of 4 there. All right. And now to solve our equation, we just have to subtract 5 halves from both sides, right? We just subtract 5 halves from both sides, and that is going to give us that x equals the -5 over 2 plus or minus, because here's where we have actually 2 solutions, one where it's a plus, one where it's a minus, the square root of 37 over 2. All right. So that is how you can solve a quadratic that isn't factorable by completing the square. Okay, you can solve this quadratic also by using the quadratic formula. Once you're good at completing the square, as you see from just the math we've done here, this isn't any harder than the quadratic formula, okay? And it's nice to be able to understand the tools we're using are some slightly advanced mathematical techniques where we are kind of moving stuff around in a way that gives us what we want. That adding 25 over 4 there, that moving the 3 out of the way. These are techniques you want to get good at because they're going to really help you to manipulate algebraic expressions and equations in a way that's going to be advantageous when you get to calculus. Okay, so take a minute and think about exactly what we did there. If you need to pause the video, that's fine. I'm going to go on to the next example. So our next example has a leading coefficient that is not 1. We could possibly factor this by grouping, where we split that middle term, that -8, into 2 pieces. If we wanted to try to factor this, we'd have to come up with something that adds to -8 and multiplies to 6, right? Because 2 times 3 is 6. I can't think of anything that, again, multiplies to 6 is just 1 and 6 and 2 and 3. And you could never get a 1 and a 6 or a 2 and a 3 to add to -8. So we can't factor this guy either. Usually, if you can't factor them, it's because there's going to be a square root in your answer, basically. Okay. So we're going to use the completing the square method. To do that, first, we have to get rid of this, this leading coefficient of a 2. And so we're actually going to just divide everything by 2. So we're going to get x squared minus 4x plus 3/2 equals 0. So I just divided everything by 2 to get rid of that 2. Okay. Now that our leading coefficient is a 1, we can engineer our constant term. So notice that our coefficient on this guy, our coefficient on our x term is a -4. So -4 divided by 2 is -2. So our b is -2. And we want to note what our b is because that's what's going to be inside our linear factor. Okay. If our b is -2, then that means that b squared is a +4. So the constant term that we need is a +4. So we're going to have x squared minus 4x. And then I'm going to give us a +4 here. And then I'm going to move that 3/2 to the other side, both sides by 3/2. And we're going to have a +4 on the other side, right? Because all I'm doing is using the properties of equality. So I'm subtracting 3/2 from both sides and I'm adding 4 to both sides. Okay, so I'm just using the properties of equality here to get the stuff on the left-hand side to be a perfect square. Okay. Now that we've got our perfect square on the left-hand side, we can factor that, right? What multiplies to +4 adds to -4? Well, that's -2 and -2, right? That's our b. But you can always just factor this regularly. But the reason we mark our b is so we don't even have to think about how this factors. Our b is -2. So our factors are going to be x minus 2 times x minus 2, which is x minus 2 squared. Okay. That's the left-hand side. And the right-hand side is going to be 5/2. I just simplified, I just added those fractions, right? 4 minus 3/2 is going to be 5/2. Okay, so we've completed our square. Let's use the square root property. We square both sides. Don't forget plus or minus when we square root. And we've got x minus 2 equals plus or minus the square root of 5/2, right? We're going to add 2 to both sides to get x by itself, and we're going to get that x equals 2 plus or minus the square root of 5/2. All right. So you might have thought that one was going to be really difficult because we had that leading coefficient that we had to divide out, but it wasn't too bad. Right, so that is how completing the square can help you to solve quadratic equations that aren't factorable. It can actually solve quadratic equations that are factorable, but usually it's easier just to factor. Okay, so that is completing the square. So now let's take a look at the third method for solving quadratics. Remember, we did factoring using the zero product property. We did completing the square using the square root property. And now finally, the third method for solving a quadratic equation is using the quadratic formula. And the quadratic formula actually comes directly from completing the square on a generic quadratic with coefficients a, b, and c. All right, so if you want to solve quadratic equations by using the quadratic formula, the first thing you have to do is make sure your equation is set equal to 0 so that your a, b, and c are the correct a, b, and c. Once it's set equal to 0, we just identify what a, b, and c are, what our coefficients are, and then we plug them into this equation, the quadratic formula. You want to be really careful there is a negative sign in the formula for the quadratic formula. If b is also negative, then you will have a negative and a negative. It will make that positive. So be very careful that you don't miss this negative sign as part of the formula in the event that there is a negative sign in front of your coefficient. Okay. All right, so we can do this example here. What do we have? B is a positive 16. A is a positive 3, and C is a positive 5. So we plug in all those pieces. Notice there's the negative sign that is part of the formula. And then we just work through to simplify it. We are going to get negative 1/3 and negative 5 are two possible answers. Okay. Let's do this other example where we've got fractional coefficients. It's a little bit trickier. A is 1/4. B, do you guys see what B is? B is a -1 and C is 1/2. So notice when I plug it into the quadratic formula that B is a -1. So we've got the negative in our equation and the negative in the quadratic formula and the negative as our coefficient. So we've got a double negatives going on there. We plug in all our pieces, we simplify, we're going to get 2 plus √2 and 2 minus √2. In our third example here, we are not set equal to 0. You have to 0 before you identify your A, B, and C. Okay. We put in all our pieces and we solve. So in this third example, notice how we ended up with a negative number under the square root. That's where we've got our I for. All right, so that's solving quadratic equations by the quadratic formula. Right. One thing I want you guys to notice in that quadratic formula, let me actually go back. This piece under the square root, if this piece under the square root is negative, then we've got a negative in our square root. We're going to have an imaginary number. If this piece under the square root is 0, then we're going to have a plus or minus 0, which is only going to give us a single solution. Okay. We call that piece under the square root of the quadratic formula the discriminant. Basically, if the discriminant is a positive number, we're going to have two real roots, two solutions. This corresponds to when quadratic equation is a quadratic, is in two variables, and our parabola crosses the x-axis twice. If the discriminant is 0, we only have one root. Okay, because that plus or minus, we're going to plus or minus 0. That's when our parabola just crosses the x-axis once. And if our discriminant is less than 0, meaning a negative number, then both our roots are going to have imaginary pieces of them, and we're going to have two solutions, but they're going to be imaginary numbers because our quadratic equation doesn't actually ever cross the x-axis if we were to graph it in 2 dimensions. You're not going to have the discriminant on your homework. I just wanted to point that out if you haven't seen it before. Oops. All right, that's the end of 2.3. Be sure to practice all this stuff and take some time to make sure you understand the techniques we're using here, not just how to apply them. All right, good luck.